Chemistry with Pastor Dan. We're looking at the last concept of stoichiometry, and we're looking at limiting reactant and excess reactant. Now, we need to define each of these. Limiting reactant is defined as the reactant that controls reaction by stopping the reaction when it runs out. So what we're going to do is we're going to have two substances, two reactants. The one that there is less of in a molar sense, a molar relationship sense. When it runs out, it'll shut down the reaction. We refer to that as a limiting reactant. The other one is the excess reactant. It's the reaction remains unreacted when the reaction is finished. So at the end of the day, it's hanging out. Hey, where's my friends at? There's no one here to play with. It's got nothing else to react with. It's still there. We call that the excess reactant. All right, so let's do a problem here. Determine the mass of calcium oxide formed. When 40.987 grams of calcium reacts with 28.994 liters of oxygen. Any stoichiometry problem. First step, every time, all the time, write the reaction. So we're looking for the words reacts with. So calcium reacts with oxygen. Synthesis reaction, calcium oxide. Balancing it up, put a 2 there and a 2 there. Now we're going to take each of these to the product. So start with 40.987 grams of calcium. Calcium is an element, so it's going to be atomic mass from the, where is my periodic? There it is, my periodic chart. 1 mole of calcium is 40 grams of calcium. Now from the molar relationship, we're going to calcium oxide. So that's a 2-to-2 relationship. So 2 moles of calcium oxide on top, 2 moles of calcium on the bottom. So the moles of calcium cross out. Now calcium oxide is a compound, so we're going to do a formula mass there. Calcium oxygen, there's 1 calcium, 1 oxygen, 56 grams of calcium oxide is 1 mole. Again, 1 mole on bottom, 56 on top. Take your handy dandy Joe Dandy calculator, do your synthesis. 40 times 40.987 times, we can actually divide those out, moles and moles. So 56 equal divided by 40 equal, I've got 5 sig figs, I get 57.382 grams of calcium oxide. Now, is that my answer? I don't know. I have to do the other one as well and see. So we're going to take the other reactant, 28.994 liters of oxygen. Now, that's not grams, that's liters. And remember, oxygen is a gas, and we're going to assume we're at SCP at this point. So 1 molar volume of oxygen is 22.4 liters. Now, to keep it straight in our problem here, I'm going to use boxes. So I'm going from oxygen to the same compound. We're always going to the same compound, going to calcium oxide. So 2 moles of calcium oxide over 1 mole of oxygen. And then this last fraction, it's not going to deviate. It's going to be exactly the same. So 56 grams over 1 mole is going to come down here as well. And my liters cross out, my moles cross out, my grams, that's what I want. Multiply, calculator, 58.994 times 2 times 56 equal, divide by 22.4. Again, we have 5 sig figs in the original, in the given information. All the rest are infinitely significant. So 5 sig figs I have, here we go, 144.97 grams. Now, which is the answer? Well, which is smaller? Once a smaller amount is generated, that reaction is done. So that means 57.382 grams of calcium oxide is my answer. What about the other one? Well, it can't exist. The instant 57.382 grams of calcium oxide, that reactant's done. It shuts down the reaction. The other one is hanging out with no one to play with, so we can't get to 144.97 grams of calcium oxide because we don't have enough of that other reactant to get us there. So therefore, my answer is 57.382. Now, what about limiting reactants here? Which reactant got me that 57.382 grams of calcium oxide? Go all the way back here. It was calcium. So calcium is my limiting reactant. That would mean oxygen is my excess reactant. All right, let's try another one. Find the mass of copper formed when 78.95 grams of copper 2 chloride reacts with 78.95 grams of aluminum. Also identify the limiting and excess reactant. All right, again, reacts with. Okay, so we're going to do copper 2 chloride, so copper and chlorine. Oxidation numbers we got to remember is that little 2 there means it's +2. Chloride is -1, Swap them down, we get CuCl2. And the other reactant is aluminum. 5 types of chemical reactions. I've got a compound. I've got an element. For 5 types, that would be single replacement. So we're going to put aluminum with chlorine. Again, oxidation numbers we know. Periodic chart. Aluminum's +3. Chlorine's -1. Get AlCl3. Who's the odd man out? Who's left over here? We put aluminum with chlorine because we got to replace the cation. So the cation, the metal, has got to be kicked out. Copper bounding up. We got coppers are good. Aluminums are good. Chlorine's not so much. So balance it. Put 2 and 3. That means we've got to put 2 for aluminum, 3 for copper. Start with our given value. 78.95 grams of copper 2 chloride. That's a compound. So we got copper and chlorine. 63.5, remember copper and chlorine, 0.5 times 1 is 63.5. Chlorine, I've got 3 times 2, so that's 71. Add them together, I get 134.5 grams. CuCl2 is 1 mole. We want to get rid of it, so it has to go on the bottom. Moles on top, always 1 mole on top. Now we go for our reaction. We're in copper 2 chloride. What I ask you to find the mass of? I ask you to find the mass of copper. So the relationship there is 3 to 3. So 3 moles of copper is 3 moles of copper 2 chloride. And then I want the mass of copper. Copper is an element. Periodic chart. 63.5 grams of copper is 1 mole. Cross everything out, we get to the units we want. Sig figs, I have 4 in the given. Everything else is insignificant. 4 sig figs, answer is 37.27 grams Cu. Answer? Don't know yet. Got to figure it out. So let's take the other value. So we take 78.95 grams of aluminum. Aluminum is an element. Periodic chart. Atomic mass, 27 grams. 1 mole of aluminum. Now, we want the relationship there. So we're going to go from aluminum to copper. So therefore, aluminum to copper, going to the same substance. We're 2 to 3. So 3 moles of copper, 2 moles of aluminum. Now lastly, the last fraction comes down exactly the same. Cross out, grams of aluminum cross out, moles of aluminum cross out, moles of copper cross out, 1 grams of copper, multiply through, 4 sig figs. I get 287.5 grams of copper, which is smaller. If we check it out here, you see that's 137. So that's my answer. That means the other value can't exist. Which is the limiting reactant? Which one gives us that smaller amount? That's that CuCl2. So that's my limiting reactant. Excess reactant is aluminum. All right, try one more here. This time I want you to do this on your own. Pause the video, okay? Pause it, work it through. When you're done, come back, start it back up again so that we can work through it. All right, here we go. There's our balanced reaction. It's a double replacement reaction. Remember, nitrate outside the box, O3s are 8, +1 -1. Lead 3 reacts with +3 -1. Double replacement, swap partners, balance it up, good to go. All right, so then we're going to take 13.98 grams of silver nitrate. Atomic mass silver nitrate is 1 mole. Relationship between silver nitrate and silver chloride is 3 to 3. Atomic mass 143.5 grams, 1 mole. Get an answer of 11.8 grams aluminum chloride. Other reaction, 31.99 grams. Atomic mass, formula mass, 313.5 is 1 mole. It's 1 to 3, so 3 over 1, same value. Answer is 43, which is smaller. So therefore, this is my answer. And my limiting reactant is AgNO3, X-react PbCl3. Hopefully that wasn't too bad. Take care. Be good. God bless.